Ladies and gentlemen, I need to come briefly back to slide number 12 in the slide set on light illumination. So I was introducing the Phong illumination model, and in particular we were talking about the diffuse or Lambertian reflection that occurs at microscopically rough material. And we said that due to the roughness of the material, when the light falls onto a certain point, like the point here, from a direction indicated by that vector EI for the incoming light, then this light is equally likely to be scattered into any direction. That is what we wrote down here. And that now means if the light is equally likely being scattered into any direction, then it doesn't matter where the viewer is positioned. Whether the viewer is here and looks at that point, or whether the viewer is here and looks at that point, or here, the user always perceives the same amount of reflected light, because the probability that the light is reflected into any spatial direction is the same. And this is the reason why we call this diffuse reflection a view-independent reflection. For a fixed angle between the normal and the vector to the light source, it doesn't matter where the viewer is positioned, the amount of reflected light will always be the same. Of course, if that angle between the normal and the vector to the light source changes, then the effectively received light will change correspondingly. That comes from Lambert's postulate, which we discussed a couple of slides before. Meaning that if this angle here becomes larger, then the effectively received light will become smaller, and if this angle becomes smaller, then the effectively received intensity will become larger. So in this respect, the diffuse reflection is depending on the position of the light source, or more precisely on the angle between the normal vector and the vector to the light source. But for a fixed angle, the reflection will be perceived equal at every position in space. It doesn't depend on where the viewer is located, and this then makes this diffuse reflection model view independent.